Hello, in this paper, we compare the haptic and augmented reality visual cues as the sensory feedback for assisting tele-manipulation tasks. We use the handheld controller for HTC Vive virtual reality system to control our KINOVA Gen 3 robotic manipulator and the RealSense camera for perception. We propose sensory augmentation in terms of haptic and AR visual cues to communicate the 4 types of information critical to the tele-manipulation task. Target locator indicates the direction and distance to the goal. As the robot approaches the target, the haptic cue decreases the strength of its continuous vibration, while the AR visual cue uses a vector to connect the robot and target, as well as provide a hint if the robot is out of view. Constraint alarm warns the teleoperator if the robot is about to hit the table, in which case the haptic cue vibrates the handheld controller, while the AR visual cue introduces high indicator and turns red if too close to the constraint. Grasp affordance indicates if it's ready to grasp the target. For haptic cue, the handheld controller will stop to vibrate. Then grasp confirmation indicates the success of grasping using a one-shot vibration. While the AR visual cue will highlight 2 boxes if the end-effector is within target region and the height is not enough, and will display the task is grasp the object successfully. We also designed 3 secondary tasks to simulate additional nursing workload, include patient evaluation, emergency on-call, and vital signs checking. The critical thinking task requires verbally respond to the simple math problems. The haptic monitoring task requires to press the button if they detect any vibration from their non-dominant hand controller. The visual monitoring task requires to monitor the simulated vital sign display in the second user interface and respond to the certain value by pressing the button. We conduct 2 user studies to investigate the effectiveness of the sensory augmentation, which asks participants to perform reach and grasp for 3 robot study locations, and user preference, which introduce secondary tasks along with object pick and place. In this paper, we try to investigate 3 research questions. Our results show a 27% and 32% decrease in time taken to finish the task, and a significant decrease in workload and increase in usability for both haptic and AR visual cue. We also found that the haptic cues may encode the information that requires immediate attention, and AR visual cues may present the continuous system status. As for the impact of additional workload, the preference of haptic and AR visual cues switched to the purpose of avoiding the cognitive workload intersection while demanding extra effort. Thank you.